In this episode, we're going to be going over how to use the quadratic formula, completing the square, and discriminant for commonly missed SAT questions for students. So here, I wrote down the completing the square, quadratic formula, and discriminant because those are going to be three things that we're going to be using in these questions. So let's jump into the first one. The first one says, one solution to the given equation can be written as 1 plus the square root of k, where k is a constant. What is the value of k? Now, here there's two ways that we can solve for this by hand, and one of them is called completing the square, and the other one is the quadratic formula. Now, which one to use really depends on the structure of the solution that they're giving us. And you guys are able to see which one's the best method once we start seeing some more problems. But for now, I'm going to use both methods so you can see which one's the best, okay? And then we'll be able to make a decision or draw some conclusions on which one's best depending on the structure of it. So let's go ahead and do completing the square first. So the goal here is to get all the variables on one side of the equation, all the ones that don't have variables on the other side. So I'm going to add 11 to the other side so that I can get all the x's on one side, leave some space, and then add 11 here. So our goal is to find a number that we're going to write here and add it so that we can now rewrite this trinomial as parentheses squared, as a binomial squared, okay? And the trick to do that, to find this value here, is to get the -4 divided by 2 and then square it. So -4 divided by 2 is -2, -2 squared is a +4, okay? So because we set this up the way we did, we can now say x minus 2. Now, I'm getting the -2 from getting this value and dividing it by 2. So since I set this up the way I did, this is now a perfect square. Okay, so these two go hand in hand. And that's going to be equal to 15. Okay, now that we have this, it's so much easier to solve for x because all we have to do here to undo the squared is square root it. So when we take the square root, we always get two answers, plus or minus. These undo each other, and we get x minus 2 is equal to plus or minus the square root of 15. Now, the last step is just to add 2 on both sides, and we get x is equal to 2 plus or minus the square root of 15. Now, if you notice, since it's in that structure, my answer, my k value, is 15. So I know that's my answer, right? That was pretty simple. Now, if we take a look at this one here, we need to use the quadratic formula. So this goes by doing -b plus or minus the square root of b squared minus 4ac over 2a. Now, what we need to do is identify the a, the b, and the c. So our a in this structure is 1, right? Our b is -4, and our c is -11. Okay, so all we're going to do is replace these in here. So we're going to say -b is -4, so that's a +4, plus or minus the square root of b squared. Well, squaring -4 is a 16, a +16, minus 4 times a, our a is 1, times c, our c is -11, divided by 2 times a, which is 1. So let's simplify this as much as we can. So we have 4 plus or minus the square root 16 minus 4 times 1 times 11. Well, this becomes a positive, and that's a +44. And 44 plus 16 is 60 divided by 2. Now, this is our solution, right? But we have to somehow make this look like that. Notice how this doesn't have a denominator, and this one does. So we somehow have to get rid of the 2. Okay, now what I often see is that students want to divide the 4 by 2 and then call it a day, and the denominator disappears. But no, we're actually also dividing the square root of 60. So here's what I would recommend, is we need to find something in the square root that's a factor of 60 so that when I take it out of the square root, it's also a multiple of 2. So for example, this is what I mean. 15 times 4 is a perfect square, so I can take the square root of it and take it out of the square root, right? So this is what's going to look like. 4 plus or minus the square root of 15, but because I took out the 4, the square root of 4, that's a 2. So if I put it back in, it's going to be a 4, okay? Now, when I divide this by 2, now look, if I divide the 4 by 2, that's equal to 2. And if I divide this 2 by 2, that's just a 1, and I'm just left over with the 15. So now it becomes exactly like this, okay? Now, here's the method. You choose the quadratic formula whenever there's a denominator here, okay? You choose completing the square when there's no denominator. Now, that's not always true, but what I've been noticing in most questions, that's usually the case, okay? So that's your answer for number 1. K is equal to 15, okay? Number 2, it says, in the xy plane, a line with the equation 2y is equal to 6.25 intersects the parabola at exactly 1 point. If the parabola has an equation y is equal to negative 2x squared plus b, where b is a positive constant, that's super important, what is the value of b? So in this case, what I'm seeing is that it's kind of like a systems of equations. And what I would want to do is to solve for y here and replace that y in here. That way I can solve that solution and figure out the value of b. Okay? So let me show you, for example. So I'm going to get 2y is equal to 6.25, and I'm going to divide by 2. Okay? So 6.25 divided by 2, that's 3.125. Okay, so since I know y is equal to that, when I come back to this equation, y is equal to negative 2x squared plus bx, I can now replace these two together and have an equation so that I can now have only b that I can solve for, right? So I'm going to get 3.125 in replacement of y equals to negative 2x squared plus bx. So what I'm going to do now is I move this over here by subtracting 3.125 minus 3.125, and I get 0 is equal to negative x squared plus bx minus 3.125, okay? So here's the thing that I'm trying to find out. What is the value of b, knowing that we have one solution? So this should have one solution, okay? So what you need to remember, and I'm going to write it down again, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. This right here, every quadratic, anything that's in the form of squared as the highest power, is either going to have one solution, two solutions, or no solution. And when we look at the quadratic equation and only focus on the inside part of the square root, this is going to be a determining factor of how many solutions we have. So if b squared minus 4ac is greater than 0, you have two solutions, okay? If b squared minus 4ac is less than 0, you have two solutions, but you don't have any real solutions. So I'm going to say two complex solutions. And then here, b squared minus 4ac, whenever that's equal to 0, you have one solution. So like going back over here, there's exactly one. So what I'm trying to say is that if I get this, if I can set up this equation where I get b squared minus 4ac equal to 0, then I can solve for b. So let's try that, right? My a is negative 2. My b, well, that's b. I don't know what that is. That's what I'm trying to solve for, right? And my c is negative 3.125, okay? So what I'm going to do is I'm going to go ahead and write this down. b squared minus 4ac, that should be equal to 0. Why? Because they're telling us we have exactly one solution, okay? So let me start replacing the stuff in there. So b squared, I don't know what that is yet. 4 times a, that's a negative 2, times negative 3.125 is equal to 0, okay? When I multiply all this stuff out, I'm going to get b squared plus, I'm sorry, not plus, it's a minus, 25 equals to 0. That is a lot easier to work with, right? So if I add 25 on both sides, b squared is equal to 25. Then I take the square root of that. Remember, I get two answers. I get b squared is equal to, sorry, not b squared anymore. It's now b is equal to plus or minus 5. But if I take a look at this answer, I only want the positive solution. So my answer is just positive 5. The key point to understand is that this right here, the discriminant, b squared minus 4ac is called the discriminant. The discriminant will tell you if you have one solution, two complex solutions, or two real solutions. So just be real careful. The complex solution also means you have zero solutions in the real plane, okay? But in this case, knowing that this tells you how many solutions you have is super, super helpful, okay? So your answer in that one is 5. All right, let's jump into this one. This is a multiple choice. It says here, which ordered pair is a solution to the systems of equation? So we don't see these as frequently. We see them way more in Algebra 1, but we treat them the same way. So what I would do is I would try to only have one variable, and that variable, since I want a solution, I want to have x equals to something at the end of the day. So I would want to get rid of the y. I don't want a y. I want the y's when I combine the two to get rid of them. Now, conveniently, they're stacked up on top of each other and they're opposite sign. So if I were to add these two, this top row minus this bottom row, here's what I would get. These two combine to negative 8x. These, they undo each other. There's no more y's. X squared doesn't combine with anything. And then negative 1 minus 1, that's a negative 2. Okay, so what I'm going to do here is I'm going to go ahead and add the 8x over here. This cancels out. I get 0 is equal to x squared plus 8x minus 2. Now, this is solvable, right? Now, here's the thing, though. Remember when I was going back over here to determine whether or not we're going to use completing the square or quadratic? We were saying that it's really determinant on this. If this does not have a denominator, I'm going to use completing the square. So let's take a look at this one over here. None of these answer choices have denominators. So I'm going to use completing the square to solve for this one. So let's go ahead and do that. So I'm going to say x squared plus 8x. And if I move this 2 to the opposite side of the equation, that negative 2 becomes a positive 2. And I leave some space here on purpose. So again, to get this here, you're going to get this number divided by 2, so 8 divided by 2, and then square it. So 8 divided by 2 is 4, 4 squared is 16. Okay? Now again, the reason we did this was so that we can write this in as a binomial squared. We chose this one on purpose, the way we did, so that we can have x plus, and if you remember, it's always this one divided by 2, plus 4, equals to 18. Now, at this point now, things become a lot simpler to work with because I can take the square root and the squared undo each other. And here we have plus or minus the square root of 18, right? We subtract 4, and we get x is equal to negative 4 plus or minus the square root of 18. Now, notice here, this 18 does not exist anywhere here, okay? Here, you're going to have to develop the skill of finding factors of 18 where at least one of them is a perfect square. So 9 times 2, this one's a perfect square. Why do we need to do that? Because this is what happens. We get, instead of writing 18, we're going to write 9 times 2. Well, we get 4 plus or minus the square root of 2, but the 9 comes out. The square root of 9 is a 3, right? So if you notice here, the only one that has that is answer choice A, okay? So answer choice A is here is your correct answer. Now, let's say, for instance, there was another answer that had the same x value. So what you would do is you would get this x value, which is negative 4 plus 3 square root of 2, and you would replace it in one of these two equations. Now, if you notice, this one's probably the easiest one, right? So instead, since this is an x value, I'm going to replace it in here. And that's going to be negative 4 plus 3 square root of 2 minus y equals to negative 1. So if I solve for y here, I'm going to get, I should be getting this, right? If I move the y over here, that becomes a positive y. If I move this negative 1 over here, that becomes a positive 1. So negative 4 plus the square root of 3 times the square root of 2 plus 1. This 1 and this negative 4 becomes a negative 3 plus the 3 square root of 2, and that is my y value, which I have here. But in this case, I just want to give you an example. Your answer choice is A, simply because you got this part here. But make sure you guys get really comfortable in factoring out, and that way you can take out as much stuff from the root as you can. Let's jump into this one here. One solution to the given equation can be written as 12 minus the square root of k over 6, where k is a constant. What is the value of k? Now remember, if this has a denominator, then you use the quadratic formula. If it doesn't have the denominator, I recommend to use completing the square. So if I use the quadratic formula, here I have x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So let's identify the a. So a is 3, b is negative 12, c is negative 7. Okay, so here, since I have a negative 12 as a b, and the negative is already in the formula, it becomes a positive 12. The square root of b squared, including the squared, I'm squaring the negative as well, is 144. Minus 4 times a is 3, times c is negative 7, over 2 times a is 3. Okay, so let's simplify that as much as we can. Okay, we get 12 plus or minus the square root, that's 144. 4 times 3 is 12, right? Times 7 is 84. And since we have a negative and a negative, this really is 144 plus 84, right? So that becomes an 8. That's a 228. Okay, so this is 228. Now this is going to be divided by 6. Now notice, we're already there. This is a 12, that's a 6. This is a 12, that's a 6. What's inside the root is my answer. So my answer is 228. Super simple. Now, if you would have done the completing the square, you would have had to find yourself, and you would find yourself in a point where you need to have a denominator, and it just gets really, really, really messy there, okay? Last one here, it says, which of the following is a solution to the equation below? Here, what I would recommend you guys do is to move everything over to one side of the equation. So I'm going to do minus 4x, minus 4, minus 4x, minus 4. That way I can have on this right-hand side equals to 0. I'm going to rewrite the 4x squared since nothing combines with that. Rewrite the negative 4x and combine these two, which is a minus 1. Okay. At this point, notice how my solutions look. We have this portion here, this portion here. We have one that's divided by 2. We have another one that's a denominator. Remember, our answers, we have two options. We can use the quadratic formula, or we can use completing the square. In this case, since we have a denominator, I would use the quadratic formula, okay? So I identify my a, which is 4, my b, which is negative 4, and my c, which is negative 1. So let's write it again. X equals to negative b plus or minus the square root of b squared minus 4ac over 2a. So here, b is negative 4, already the negative in there, so that becomes a positive 4 plus or minus the square root of b squared. B squared is negative 4 squared, which is 16. Minus 4 times a is 4. And then c is negative 1. Divided by 2 times my a, which is 4. Okay, so let's go and write that out. So here I'm going to simplify it. I'm going to get 4 plus or minus the square root. These three combined to a 16. 16 plus 16 is 32, divided by 8. Now, notice here how this is not in any of these formats, right? So what I'm going to try to do again is try to find a factor of 32 that's the biggest one where it's a perfect square. And it turns out that's 16 times 2. 16 is a perfect square. So if I do 4 plus or minus the square root of 16 times 2 over 8, that means I can take out the 16 and make it a 4 outside. So it's going to be 4 plus or minus 4 square root of 2 over 8. Now, again, a lot of students, what they do is they try to simplify one of these and then they don't simplify it to this one. Since there's a plus and a minus, not because there's one or the other or both, once there's a plus or a minus, you have to divide both terms by 8. So 4 over 8 reduces to a 1 over 2. And then this one here also reduces to a 1 over 2. So I'm going to get square root of 2 over 2. Now, which one has that? This one cannot be it. It doesn't have a denominator. Just know that this can also be written as 1 plus the square root of 2 over 2. So my answer is going to be D in this case.